In this video, I will be talking to Senior Software Architect Chad Michel. He is the co-author of the outstanding book, Lean Software System Engineering for Developers. We discuss straightforward ways you can write better code immediately, how to design systems that are adaptable and will flourish for years, all while preventing code rot. We have an in-depth analysis on the trade-offs of your team purchasing a tool versus building the tool yourself, plus a boatload of practical, ridiculously easy tips to improve your code quality, get projects done quickly, and get you and your development team into the development pit of success. Let's go.
Cloud Guy Chris. Beep. Boop. Blonk.
Subscribe. So, first off, what are some basic concepts that will help developers write better code?
There's potentially a lot to that answer. But probably one of the biggest things I'd focus on early in your career is really becoming a good test writer. If you can write good tests to go with your code, you're probably going to learn quite a bit. And probably some of the big reasons for that is if you write tests for your code, you have to become a consumer of it. I think as a consumer of your code, you're going to be naturally thinking, can I simplify it? Can I make it easier to interact with? Those are things that are really going to help. Sorry, you're going to say something?
Oh, I was going to say something along those lines. So are you talking more of like a test-driven development, or are you talking you write your code and you write some unit tests afterwards, or what are you kind of thinking?
Either one would be fine. I think you're trying to help someone kind of get their career going. I think either option is fine. You can either start with, writing the test first, or start with your code and then write the test. I don't think it really matters, but I think that kind of being forced to consume your code is really valuable. The other kind of concept kind of baked in there is really trying to keep things simple. When you're writing code, I think it's pretty natural to try to always come up with the most complex or the most clever solution to a problem. In general, you're never going to love the clever solution you came up with 6 months ago. I think every developer has come up with some great idea they thought was great at the time, and then 6 months later, they're like, oh my, I can't read this. Keep things simple, write good tests for your code, and that's going to get you a long ways, especially when you're starting out your career.
Awesome. And then I'll ask one more thing about unit tests. I've always heard this. Unit test is kind of like love. You'll just know when you need it. So is that the sort of thing, how many, just as a rule of thumb, if someone's writing some new code, how many unit tests is it, one or two? Or are you testing a couple different scenarios, or what's your thought process on that?
The tough answer is it's going to depend. I think a lot of things in software, someone's going to give you some sort of, well, it depends answer, which is unfortunate. If you're coming in looking for an answer, it's I want the number 7, right? Or something like that, very concrete. It's obviously going to be somewhat dependent on the complexity of the code. If it's incredibly simple, you might be able to get away with 7 tests. But in many real world systems, it's going to take more than that, and potentially quite a bit more. If you're writing something with a complex algorithm, you're maybe looking in the hundreds of lines of codes, or maybe even thousands of lines or thousands of tests. Probably some quick ways to kind of narrow in on that, though. And one of them is using code coverage. I'm not a big fan of code coverage because it kind of, if you're not familiar with it, code coverage, when you run your automated tests, you'll get some sort of code coverage number. That code coverage number typically is showing you how many lines of code in your business logic code solution actually have been hit. Are you hitting 40% of those lines of code, 50%? And I think when people run code coverage, that's often what they're thinking about. They run their tests and they get some sort of code coverage number. I'm not in any ways advocating we look at that number. But what I do think is really useful is a lot of those tools will show you which lines have been covered. They'll show you often Visual Studio will show you, I think in green, the lines that have been covered, in red, the lines that haven't been covered. So one good place to start is run your automated tests and then go look, hey, what's been hit by these tests? You may find that you have really great coverage in a few areas and completely miss some others. So it's going to give you that real quick feedback on, hey, am I hitting some good things or not? Or maybe I'm not. The other thing is factoring in, what is the real core business logic for this project? Anything that's core business logic, we do want to try to make sure we get all of that turned to green. In those editors, we try to really shoot for that 100%, a really high number, especially on that core business logic. So I'd say it's kind of focusing on running those tests, looking at code coverage as a way to find what you're missing, and then write more tests to try to get that up. I do want to throw out, though, kind of, I'm saying all this, it sounds like just throw more tests at it. I think that's a little bit, can be a danger. And anybody that's written a lot of tests has probably seen this, is that is a weight you have to carry for the rest of your life on that project. And it can be non-trivial, especially if you have a ton of tests. You may end up not wanting to make changes to it because one change here results in 30 tests failing. You don't want that scenario. You don't want one small tweak resulting in a ton of failures potentially. So you are trying to minimize. In a perfect world, you would have the minimum number of tests to ensure that you kind of hit all core business logic, all the lines of code, hitting it with all the different kind of data paths that it could be in there, and hitting it from another perspective of making sure we hit all the exceptions. Those would be kind of some of the things I would be thinking about as you're writing that test. I do think when you start out in coding, it's pretty useful to have some of these heuristics I'm kind of talking about, like looking at the green versus the red, looking at the number of, making sure you're handling all the data paths and all those things through there. It's pretty useful. As you get more experience, it becomes easier and easier just to almost write those as you're going. But that takes a little bit of time. If you're getting started, I'd say be a little more prescriptive, spend a little more time doing it. But you're not shooting for taking something simple and ending up with 1,000 tests. That's not good. There is kind of a balance there. But unfortunately, back to your original question, I can't give you the number 7.
First of all, that's a fantastic answer, because I think in the beginning you get these rules of thumb in your head. We go, I got to write 3 tests. They'll be fine, like an exception, a good path, and a bad path. But as you get further along, you start to realize it depends. Seems to be almost like the go-to for all this stuff. So I completely understand what you're saying. So let's jump into the book. Great book, a little bit here, and buy it. The link will be down in the description. So one thing you and Doug talk about a lot in there is information sharing, and not in the code way, but in the beginning planning really of any kind of project. You have a beautiful matrix you make. It has 4 quadrants. One of the quadrants is known to yourself and known to others. One quadrant is known to yourself. One quadrant is known to others. And then one quadrant is unknown to all. So I think, and maybe I'm just feeling this way, but I feel a lot of other developers do, that there's like this stigma, this idea that you don't want to ask too many questions at the beginning because you don't want to be looked down upon as like you don't know what you're doing. And then the other thing is, some developers I've known, and I'm definitely not guilty of this, of over explaining things. So where do you kind of draw that nice line so you can, or do you have a process? And I know you go into it in the book, but I'm just curious, like what your thoughts are and setting up effective information sharing before and even during the project.
In general, as an industry, I'm just going to call all of us out, including myself. I don't think we share enough information. So if you think you're sharing too much, you might be still not sharing enough. I think we try really hard at Don't Panic Labs to share a lot of information, to create some good artifacts, create things before we get going on a project, have a lot of meetings to kind of continue to share those things. Still probably at all points not sharing enough. And I think from the kind of the original part of your question, which was, as a developer, how many questions, am I asking too many questions? The answer is probably not enough. I think in the education world, there's often kind of this bias towards don't just ask the teacher, you got to learn it. And there's some value in that. If you're trying to learn something, I often think there is some value in kind of struggling through something. But as a company where you're paying people to get software done, you often don't want to let them struggle too long. And I think there's often a case where like some senior engineer probably can give someone the correct guidance in 10 minutes, or that engineer can spend 2 days trying to figure out that on their own. There's no way almost any company wants to pay that investment of that 2 days. They probably learned it better. In all honesty, there's a good chance that by doing 2 days of suffering, they maybe do know it better. But that's very expensive. That's a very expensive way to learn. And I think almost no company wants it that way. New developers, I think people it's almost seen as a positive, like when you're reviewing a new developer, thinking, how are they doing? If you hear, oh, they're asking a lot of questions, I'll be honest, most organizations can be like, oh, that's a good thing. They're not going to view it as a negative. So don't. If you're coming in, getting a job as a software developer, you're like, oh, I'm worried I'm going to be asking too many questions. Force them to tell you to stop asking so many questions. You're probably not asking enough. You will ask less questions over time, especially around the technology. You're just going to start picking things up. If you have a question about how to do this inside of this project, feel free to ask someone. Most companies are running some sort of agile process, so they have probably a stand-up every day. Maybe bring it up in there. Is there anything that's blocking? Well, I have a way to do this, or at least an idea, but does anybody have a better way? Someone probably can give you, one of those senior engineers can really point you in a better direction really quickly. And over time, you will become that expert helping others with those answers. But initially, ask a lot of questions. And if you're an organization, or like if you're someone more on that senior side, providing more information out is good. If you're like an architect trying to help people, you're probably not providing enough. You can probably provide more and it'll be good. So I think we're all biased to think everyone knows what's going on. And I think in reality, that's not the case. And it's not because of any fault of their own. Sometimes they're literally never told this something. You kind of assume people have picked something up by osmosis. They probably haven't. Provide more information. And in this hybrid kind of world we're in now, I think it's even more important that we do it with good documentation than ever before.
So, okay, I got a couple follow-ups that could be a whole nother discussion, but real quick, what do you recommend for documentation? Because I think that's something people struggle with. Should it be in the repo with like READMEs? Should it be on something like Azure DevOps? Should you get Confluence? Just real quick, I'm just curious your opinion on where you like documentation.
This is another one where I'm going to unfortunately give you the it depends answer. I think this one to me, though, matters more. What does that team or company or organization think is the best spot? And be consistent. Because if part of a project does it in one spot, part doesn't in another, that's the worst situation. Ideally, you want it for this project. It's in the README. I think that's a fine answer. I mean, you can document most things there. There are certain circumstances where I think like that README notion breaks down a little bit, like architecture diagrams, mock-ups. You're quite possibly better off linking out to somewhere else, maybe in the README saying, hey, this is where the mock-ups are at. It'll link out to an Adobe XD site or something. So just calling that out there, it is not one size fits all. There's different types of artifacts, but definitely having those mock-ups, architecture diagrams, and all those. I actually like having it somehow related in the source myself, whether it's in a README or documents within the source, because that way, if I download the source, I feel like I have everything to get started. I downloaded a project earlier today, and the kind of lead developer that had it set up, there's a nice README file, and the very first thing is, how do you get this thing running? Just steps right through it. That's the kind of way I like things to work. It's all right there. The architecture diagrams were in a documentation folder right within that repo. So everything was right there. I could just jump in, look at it, and go, oh, this is how it's going to work. I didn't have to go anywhere else to get that information, or at least all the references to that other stuff would be all right there included in the source.
That's absolutely beautiful. I love that idea on a project basis too, because I think you see a lot of companies who this team does it over here and this team does it over there. So, well, let me step into another thing here that you guys get into a big bit. And this is something that I've worked at companies where they've really fought this, is the concept of rework. And so for people who don't know, rework, I think every company might define it a little bit differently, is I do an item or a task, it gets through QA, maybe it gets kicked back at QA level. After you've merged your code, you move on to something else. Now you got to go back and rework on it. And so you and Doug really get into this very well, because you talk about how impactful it is. And you even give an example where if you have 4 developers on a team and the rework rate is 50%, you drop it down to 25, that's essentially a new developer. So the question I pose to you is, what are some things teams and orgs can do out there to help reduce that rework rate?
There's, quite a few things. Probably one is getting a sense of what is the source, and that'll help you quite a bit. And the reason I bring that up is there's kind of a classic notion that a lot of that rework comes in through bugs, and bugs produce rework. I'm not pretending that they don't. I think some of the research that's out there, the number one source of rework though isn't bugs, it's requirements. So if we're going to try to fix this problem, and we're trying to fix it by purely squashing all the bugs, which is useful, I'm not, again, advocating against that. If more of it's occurring because of requirement problems, we're potentially not fixing the right source. Now, having said that, I think you'll never get down to that. You mentioned taking it from 50% down to 25%, you effectively gain a developer. We're not going to get to that level by just cutting bugs, probably cutting requirements and improving our design. It's probably going to be a combination of all of them, because we're never going to get to zero rework on all or any of them. But our goal should be to drive that down. But that first thing would be probably tracking it and tracking to a degree, where do we think that source originated from? And we don't want to get too punitive. I think this concept, we have to be careful. We're not pointing fingers back at why we're doing this. I think the one thing in an organization we always want to be focused on, this is where we're at now. Get some number, figure out why, and be more focused on kind of that solution focused. How do we get better next sprint? Or probably even more importantly, the next release. Like for that next release, what are we going to do to try to reduce some of that rework? And you're going to have to try some things, potentially more documentation up front to try to get that number lower. Again, there's probably not going to be one magic silver bullet. Might be more testing, might be changing how we're doing some of our automated testing. But driving that rework down does have a big benefit, especially if you're like on a big project and maintaining it for years. That number can be substantial to your point to the point you kind of talked about, if we take that number from 50 to 25%, we could gain a developer. Developers are expensive. That's a big win for a team.
And I'll go back to one thing you said too, because I worked at a place where we didn't pay attention to rework, and then all of a sudden we started tracking it. And one thing I've noticed is with developers, once you start tracking something, anything, people all of a sudden they're smart and they go, you know what? Let's not have that number be high. And so putting that rework, even just a measurement or I don't know, some sort of cool graph in Excel that people can look at on sprint reviews, like I've seen that work. And you guys talk about that in the book too, that being a metric that you need to track a lot.
Yeah, I 100% agree. And I do think you point out something. You always have to be careful what you track, because you don't want to create a situation where people are trying to game a system to improve things or things. But I think rework is such a high value, especially on a long running project. It really does start to eat up time. It's worth the tracking. And ideally, being able to say, hey, we're at 50% now, and setting goals and trying to reduce it has a huge win for everyone.
And I'll add to that, as a developer, there is very few things that kind of hurt your soul. That when you're like, I've pushed this beautiful feature out, everything's great. You start picking up the new work, and all of a sudden you get a thing that goes, oh, this part doesn't work. You go, oh, no, obviously you're testing it wrong. But
yes, it's always
it's working as designed.
Yeah.
Okay, so this one I want to go kind of high level, because again, we could do a full another hour on this. In the book, you guys talk about breaking down kind of a made up order notification system. Essentially, an order comes in, an email is sent out. So you and Doug kind of go into the thought process of breaking it into components, and then you kind of do a real big, almost like a master class on breaking down the system into subsystems and decomposing that so teams can build it. I guess the kind of the question I'm asking now is, what is your thought process when you're given a project? Because I know, again, it depends, but like I'm sure there's steps in your head. You go, okay, this system's coming out. How do I want to break it up? Or I guess I'll leave it to you. How do you break something up?
First off, this is, we're talking about kind of an e-commerce system. Doug and I have had the opportunity to work on many e-commerce systems are kind of in this space. We've made a lot of mistakes. So we have a lot of good expertise on how not to do things in an e-commerce system. So it was a good use case for us to start with, because we had lots of failures to draw on. So there's kind of that. I think it's a good one from us to start with. The example in the kind of the book, we're kind of taking something that starts one way and slowly kind of evolves, right? Which actually is the way a lot of software kind of goes, which it's often going to kind of slowly evolve over time. But kind of thinking back to when, kind of projects start, when we're originally designing systems. And Yuval Lowy, and someone from iDesign, he has a book. I'm going to promote his book here right now, Writing Software. It's a great book. He has a kind of a process, he calls it the method for breaking systems down. We don't do it exactly kind of like in there, but we borrow a lot of things from that. But probably one of the first things for me is getting a really good sense of what are the core use cases of the system. What are the things the system most needs to do? And then trying to design an architecture to support those most important things that system needs to do. Systems need to do a lot of things. Almost every system has some sort of reporting notion. There's always some CRUD screens over somewhere for some admin stuff. Let's focus on what is this system really built to do. Let's do a nice architecture diagram for that. And when we're breaking that down, there's a lot of different ways we could be breaking down that architecture. We tend to follow his lead on this, and he's a big fan of volatility-based decomposition, or designing for change, as we often kind of call it instead. which there we really are trying to break into these individual areas that we can evolve independently without having to destroy the rest of the world around it, which I think we've all been part of that systems where to make one change, we have to basically change everything. And that can happen in any system. Our goal is to really reduce the likelihood that that occurs. So that's kind of like, we're looking at how we break something down. That's kind of our initial approach. And hopefully by kind of having it broke down by volatility, as new changes come in, as that system needs to evolve, when we have to make changes, we're never to make one new feature to do one new thing. We ideally don't have to touch everything in that system. Because if every change requires you to touch everything, it becomes a mess in a variety of ways. One, it's a developer headache. You have to touch everything. Two, it's a source code kind of headache. Everybody's touching the same things. I mean, merge conflicts all over the place. It becomes kind of a testing problem, right? Because everybody has to retest everything on every change. It also, to make any change in the system, and maybe this is even more important, is the developer kind of has to be kind of an expert on everything and maintain everything in their brain the entire time they're making that change. Their field of view is really large. We don't want that. We want to be able to narrow people in so they can only have to focus on one small area while making that change. So kind of back to your original how we kind of approach it, that's kind of, I'd say, our approach for most projects. We're going to try to find those core volatilities and try to encapsulate those individual volatilities within that project.
I love the idea of the field of view, because I've had that problem too, where you start digging in one thing and you have to go down 1,000 different paths. We talked about unit tests. That sucks when you change one thing over here, and then you have to change unit tests over here. So I think that's a great way to go about it. I wish more people would break stuff down like that. In fact, going into our next thing, because this kind of piggyback off it, is you guys use this awesome term in there that I haven't heard, but maybe it's a common term, is code rot. I've never heard of that before. Is that something you guys made up, or is that an actual term in software development?
Given that the book is largely a synthesis, I think of kind of, we're pulling from many different sources. Mm-hmm. I mentioned Javal. I mean, Fred Brooks, I'm sure, was pretty influential for us. He passed away this last week. David Parnas. There's a lot of good sources in there. So I'm assuming it's coming from another source right now, but I can't think of where. So I'm assuming it's a term in software. I don't think it was completely ours, but kind of this notion of software decay, or in this case, software rot. I think it's something we see. I think every developer that's been on a project that's lived for years feels. Everyone has felt this that has been around for a while. I mean, there are people that maybe been in the industry 6 weeks, haven't. But if you've been in the industry for years, experienced some projects, you've probably ran into something like, ooh, you get in there and you just feel it. There's probably no tests. The whole thing looks like there was 12 different people duct taping it together. It feels like there's maybe, if it was more of a physical thing, there was just wires running all over the place and no one really knows what they are. And you can trace them. You can kind of trace the wires if you really try, but it's really hard if they're a nest to really trace them and keep them mentally separate. I think all of those problems we've experienced in software. And it's really not what developers find fun. We sometimes talk about this concept of funability. One of the most important things for us is we want software development to be enjoyable. Most of us enjoy writing software. I guarantee you do as well. But when we get into those situations where we're looking at something that's really rough, that's probably not one of the things we're most enjoying, right? We enjoy creating new things, not using 2 wire testers and trying to trace 2 lines and keep track in our head what line connects to what.
Right, 100%. And I've done that before too, where I go back to code and I say, "Oh, let me blame this. What moron wrote this?" And I realize this was me 6 months ago who wrote it. And I go, what did I do?
Actually, you bring that up. That was one of my first experiences as a developer. I still remember this from years ago. I was trying to think. I had that moment. I was like, well, who did this? And I was at the company for probably less than a year. So it was one of probably the very first things I did. And then a year later, I don't know, I was looking at it and going, what idiot wrote this? And so I'm looking back at the source and I go, oh, it was me. So I've had that moment as well.
It's you right there. I know exactly what you're talking about. So in the idea of somebody what's the way to say? Okay, in the beginning when you're building systems, you learn a certain way you go. Well, now it's easy. This is the way you build software, right? But then as you get more experience and you start dealing with trade-offs, and this is where we're going to go on this one, in designing systems. Now, we could come at this 1,000 different angles, but selfishly, I kind of want to get your opinion on one of these because I run into this all the time. So the trade-off you talk about in the book too is you got something, you could either take the out-of-the-box solution, you could get a piece of software or something else that works, that does it, but it doesn't quite have all the features that you want. Limited functionality, but it's there. You don't have to maintain it. Or you or your team could build new custom tools that need to do exactly what you want it to do. However, then you got to develop it and you got to maintain it. And this is something, again, I've dealt with a lot at work, so I'm curious, kind of what are your thoughts, or what are some of the trade-offs you look at when you say, should we use the thing out of the box or should we build it ourselves?
This is a trade-off. We build a lot of software projects for other companies. So this is a trade-off I feel every week this comes up. So I have felt this one a lot. And many other developers do as well, by the way. I don't think this is unique to starting new projects. And a good example, should we use this UI library? It works and does most of what we want, but we have to choose, we can't do second level sorting in this grid. It only supports one level sorting in this grid. This is maybe a real example I've ran into in the real world. I think it actually is. So we're kind of like, what do we use to make that trade-off? Probably for me, the very first one is I like to ask myself a question: is this, whatever we're making this trade-off for, core to the business functionality and success? If it is core to the business functionality and success, I'm going to be more biased towards build than buy, because I want that control. I want the ability to take this over later, if that is the case. If this is some sort of kind of side feature, not core to the functionality, it's for some admin pages or something, way biased towards buy. Way biased towards buy. Because at that point, it's probably not going to be the make or break for this product. It's probably not going to be the make or break for this company. Now, all of this kind of has, we have this buy versus build. All of this, we always need to be doing some sort of dollar equation. And I think usually we will find it's cheaper to buy some product than to build. I think the numbers are usually going to work out that way. And I think that's kind of implied, but it's not always going to be the case either. A good example would be if we feel we can buy this, but we have to make a ton of customizations to it to make it do what we want. Then I do think we're in this world. We need to make some good estimates. How much effort is it going to be to really customize this to what we want? Because I'll be honest, I've seen us do this ourselves, where we think, oh, this UI control gets us almost the way there. And then we decide, oh, we need to customize the heck out of it. And at some point, you have to ask yourself, would it have been easier for us just to have built it from scratch? And I hate the idea of building any sort of UI control from scratch. There's a lot of them out there. Seems like not the best investment of money. But if it's core to what your product needs, I think you have to really be asking yourself, and if we have to have this feature implemented the way we feel it needs to be, or if we feel we're going to have to make a lot of changes to it potentially based off user feedback, and the buy option is extremely limited, then maybe we need to be more biased. Now, the only caveat, I'm going to put one more little slight caveat on this whole concept, would be time to market. I've been talking a lot about cost, which is important. Sometimes we're making decisions, especially in product companies, where there's this conference. There's a conference December 5th. We've got to have this feature in by December 5th. In those circumstances, the buy is even more viable or a better option, because we're going to get something that's closer to what we want out of the box. In those circumstances, we may have to make some trade-offs. We don't get every feature we want. But that buy option becomes even a better option under that extremely tight time frame often. Now, again, if it has to be a certain way, if we have to have that control, it's maybe, my example maybe breaks down a little bit. But to me, it comes down to, I'm going to go back to my original answer. If it's core to the business, I think it's often more valuable to build. If it's not, if you can get away with one vendor or another vendor or your own, probably just picking a vendor makes sense.
I can see that. And just listening to what you had to say and your previous answer about kind of planning for the future or changes, because every project we've been on always starts out one way. and they go, we just needed to do this little thing. And you go, oh, well, I can do that. And then you find out 2 months later that it also has like 15 other features that go along with it. And so I think that's something that just exactly what you talked about, you kind of have to plan into when you say, should we buy it or should we build it? And what do you have anything in your head, or is it just straight up experience to kind of look a little bit forward? And we're going to get into that too in a little bit, but essentially seeing forward in a project to go, we need to just build our own solution, because in my past experience, I've seen this type of project morph into a different thing.
You're hitting on some good things that probably there is a little bit of experience benefit. There's probably also people that have worked at a company for a while have a little bit of probably foresight. If they've worked at a company for a while, they might be able to see around that next corner a little better than someone coming in completely cold. So a little experience or some experience in the company, both would probably give you some advantages there. But you can always do a few things. And one is think through, we're building this version right now. Go through and get epic level backlogs. Where do you think the next few versions are? They're not going to be accurate or perfect. There's going to be changes to them. But if you work with kind of those product owners, you can probably get a good sense of what that next version will be and the version after that. I mean, the farther out you go, the less accuracy you probably have. But be thinking about, where do you think this product needs to go? And then back into, well, how am I going to support these next features on this platform? And as you're designing, even like an initial build of a system, you often, if you're building an MVP, you often want to know what that V1 is going to be adding to it. Probably even that V2. That'll allow you to better build a system, whether it's that encapsulating volatility, whether it's designing the UI. I know our UX staff at Don't Panic Labs is always interested in where the UI is going to try to think through. We don't want to paint ourselves into a corner where we have no way to support that next feature. So all of those things have to come into play. And all of them are really relevant from that buy versus build, because if you know the control works for what you need today, but the very next version of the software, it's completely useless, then that's maybe not a great buy decision.
Okay, this is the last one, then we're done with this topic, because I don't want to beat it to death with the horse. But generally, in my experience, what happens is maybe you're working on a new feature or something like that, and you get tasked with an item, a spike that says, hey, go look at this new thing.
Yep.
Now, you just mentioned one of the things is you ask the UI team and say, hey, where's this going to go in the future? But is it on the developer then to go out and start asking these people, asking product owners, asking project managers, asking UI, UX, or how do you feel it should work when they're stuck on the spike going, should we buy or build? How do they go about doing it?
I think, as an organization has to decide who's really responsible for the technical success of the project. Ideally, it's one person. Like if you're dealing on a really, really large project, that maybe becomes difficult. But ideally, it's one person, whether it's a software architect, whether it's a development lead, someone has to be responsible for that technical success of that project. And as they're looking at that results of the spike, because I think the developer should be more responsible for, you're asking them a question. Will this control support these features? And they're probably never going to give you an answer, yes or no, right? They're often going to be yes, but sometimes it's a problem. And actually, that's usually the answer, right? You never get a yes or a no flat out. It would be easy. Then you say, okay, yes, no, we're probably fine. And then there's a little bit of a costing and timeline aspect that has to be factored in as well. But it's pretty much never that clean. So that technical lead has to kind of be able to look at this information, make this judgment call, whether it's a lead or an architect, and go, hey, what we have now, this kind of information, this allows us to be successful now, but will this work later? And that lead probably does need to work with that project manager and project owners, or product owners, I should say, product owners, to see, does this fit in there long term? So I think someone has to be kind of responsible for seeing around corners on that project. Everyone has to be looking around corners, I think, as developers, but I think someone has to be ultimately accountable for that, and keeping that big picture in mind. Because one of the things that's kind of hard sometimes is you're looking at this very narrow window. And do we know if this is good enough? Some developer might be asked, will this system send emails for us? Yes, but that tech lead might be going, well, yeah, it sends emails, but I know we're going to need to send SMS messages 6 months from now. How will it, this doesn't send the SMS messages. We need to move on and try something else. So those sorts of things, I think someone has to be responsible for.
I think that's a beautiful point, especially reaching out to other people, because I think there's a lot of developers who, when they get tasked with something like that, they have to be the one that goes yes or no, when instead they can kind of lay out the facts and then kind of collaborate on, especially with the technical leads and the more experienced people. So completely great answer. Okay. When I was reading chapter 5 on this book, it's like you guys wrote that about me. So you get into the kind of the time sucks or the things that really mess up a developer's day. So you got your meetings, framework changing underneath you, demos not working, and the disappointing looks of project managers. Yeah. And then you start talking about the pit of success and really getting developers in that pit of success. So maybe if you could tell us a little bit about that pit of success, and then how both developers and technical leadership can start to shepherd people into that pit of success.
That chapter was one of my favorites as well. A little side note, just kind of this talking through of kind of like how bad things can get quickly for people. I think I find that kind of interesting. And we interact with a lot of other customers, or a lot of people, we help innovators come and build a project. When they do that, or especially if they're a big corporation, we'll be talking to them and sometimes helping them working with their developers. And when we talk to those developers, one of the first things that becomes pretty apparent is many of them don't have maker schedules at all. Many of them have manager schedules, but yet are being tasked with getting software built. And I think that's a huge mistake in organizations. And as a side note, we've made that mistake as well. It's pretty easy just to think, add this developer to another meeting, add this developer to another meeting. Before you know it, that developer had at best a 1-hour window to work on stuff during a day, and it was all cut up with other meetings. If that's the case, they probably weren't really effective. They probably felt like their day was one big mess. And I think a lot of organizations suffer that. We've kind of done that to ourselves. We try really intentionally not to let that happen, but I think what we see is we do a really good job at it, slowly gets worse, and we have to go, we have to stop some of these meetings and kind of push them back. It's really easy to let those meetings come into play. And I think just kind of setting people up, you mentioned the pit of success. Setting people up to be in that requires a holistic view of the organization. One of it is kind of that maker schedule. I think it's Paul Graham kind of that concept of managers versus maker schedules. I think that's really important. I think enforcing certain good behaviors, good automated tests, good build processes, ensuring code reviews occur before things go in, just creating a best practice for an organization. This is how we're going to do things, and then sticking with it to help ensure developers are going to do things the right way. Their code's not going to magically get checked in and go straight to production. Someone's going to review it. Some build processes are going to hit it. It's going to go to QA. Potentially some QA is going to look at it as well. Having things layered in place to really give people what they're going to do is going to result in success. Because none of us, and I think every developer's had this moment where they had something go wrong in production and they're like freaking out. None of us want that. We all want to be in that pit of success where whatever they do is going to result. If they just do things the way the organization wants them to, they're going to keep falling in that pit of success. And getting to that pit of failure is harder. You almost have to go out of your way to get into the pit of failure.
That's awesome. And in fact, you mentioned PRs. Real quick, like what do you count as a good PR process? Because I've heard it and I always believe it, that like a good peer review is one of the best things for preventing bugs and keeping your system tight and your code good. So do you have kind of just a mental checklist when you look through a PR, or do you guys actually have a written checklist that everyone must follow?
We have a written checklist, but I guess maybe more important than that, well, I think it is a good thing to have some sort of checklist. What are people looking through? But I think it's also really valuable on a project or in one area of a project, have someone that's responsible to making sure all of those kind of fit within kind of the design for this system, to make sure that system maintains a level of conceptual integrity. So it doesn't look like we don't want a system that looks like it was built by 10 different developers. We want it to look like it was built by one mind. And that having that one person kind of reining that in, I think is really valuable. Now back to the checklist, it's good to have, we should have standards for naming. We should have standards for method signatures. Everything should have some level of standards, and that's really good. But one other thing is a coaching aspect. And this is where I think the tech lead or development lead. We call them pod leads at Don't Panic Labs. That person can have a real huge benefit in an organization of coaching those other developers. Some of the best things you can do to ensure the quality of those code reviews aren't around some of those technical things. It's about keeping those PRs small. If you have a really large pull request that has tons of files, tons of lines of code, the chance of finding bugs or issues goes down on those. There's some really good research out there around that. Keeping those PRs small is really useful. Pre-documenting your PR, going through and looking at it. I don't know how many times I've got ready to submit a PR and I'm looking through it and I'm like, oh my, this won't work. What was I thinking? And I never had to submit the PR because I found it myself. That's really important. And that's really important for preventing rework, because rework really begins, I talked about that earlier, the moment we engage someone else to interact with our stuff. We don't even have to, because you can just look at it yourself. And if you just walk your code in that PR, in that code review, before asking someone else to, often you'll find a ton of problems yourself. You're like, I don't know what I was thinking here. But keeping the number of lines small, keeping the number of files small, kind of walking through it yourself, pre-documenting, if you think there's something weird you need to describe or describe why you're doing it, put that in there for that code reviewer. Now, the one other thing that can come up is, should you do them as kind of a pair, walking them through together, or should it be more asynchronous? Just you submit it and someone kind of reviews it. I've been part of both at times. I think as an organization, we probably do more of them asynchronous. Someone submits them and someone reviews them. But anytime you have one that kind of is violating some of those rules, a lot of files, really large, I think it starts to become more valuable to just bring the two people together and discuss it. Or if it's something complicated, I think it'll often go a little quicker as opposed to going back and forth for 2 days with comments. You don't want a PR to sit there for 3 days, comments going back and forth. There's a point where it's just quicker to get into a meeting, get it over with, get through it, and move on.
I 100% agree with that, because I've been at both ends of that, and it always goes faster when you get to, especially when you get to the point when you have a really big PR for maybe a feature branch or something. Just talking through it with the other person and testing together. I've done that a lot, and that's been very helpful. One question. Okay, so we get in the book, and you guys start talking about a chief engineer in the book. So first off, I think a lot of different organizations have different titles. So what's the difference between a chief engineer, a principal engineer, or a staff engineer? Or are they all kind of the same thing?
I think this is going to be, unfortunately, what that organization kind of defines it as.
Okay.
That principal engineer, many organizations probably kind of close to what we're looking for here in the book. But with that chief engineer, as defined kind of in the book, we're really wanting one person defining kind of that direction for an organization. This is the technical direction, defining kind of those education paths, defining how we're doing things, defining, kind of what is the design for this system, and kind of maybe not doing all the work themselves, but helping to guide, kind of that work as well. And I think that's one thing that many organizations don't have. I think many organizations kind of have some notion of some sort of more like a development manager. They're the person that's doing the evals for all the developers, right? But they're kind of loosely defined on who's making the technical decisions. I think it's really important to have one person making those technical decisions. One person that's really responsible for that conceptual integrity. One person that's really responsible for what we want our organizational direction to be. It's something that's kind of missing in many organizations, not all. There's a lot of organizations that do, but there's sometimes it's missing.
I will ask you a follow-up on that one, because I know with some of the bigger organizations like Netflix or Amazon, it's very sexy to have all the different teams doing their own stack to build their own microservice. How do you think that chief engineer role plays with them? Is it more of a project level, or is it a company level or domain level, or is it just non-existent and you say this team builds this service and hope it just works? Or what do you think?
I haven't worked, at Netflix or seen how that's going for them. So it's really hard for me to kind of jump into something of that size.
Okay.
Each one of those kind of areas within Netflix potentially is its own like project / mini company almost. So maybe it is more okay to have many of these within there. The one thing I would throw out, and Netflix is really, really large, so maybe it's more okay to kind of have that federated, a little more spread out. But I do wonder, you'll often see a decent sized organization, like maybe 100 developers. And what's happened in that organization is each project's been kind of ran under its own world this entire time. There's been no consistency. And what you end up with is kind of a bunch of very independent silos within that organization. And we've seen this kind of interacting with companies. Each one of those silos is kind of like its own world. And what you end up with is not really a company, but these own little things, which you could see as good, right? The volatility you might think is better encapsulated that way because they're kind of their own little world. But because there's no one really looking at the overall interactions between the system, you could still have the coupling being really horrible because no one is really guiding that overall process, mirroring or kind of hooking all of these pieces up. The other thing you'll see with a system like that is there is no real organizational guidance or flow or process or tech stack that's common. And often in real organizations, you'll have one project that, hey, they don't need to do as much work right now. And we'd love to take their developers and move them over here. Or we're going to hire some new developers and we don't know where we want to put them. If your organization has every little group doing their own little thing, it's pretty hard just to bring someone in generically into that organization. It becomes pretty difficult to move people between teams. It's pretty difficult to do training across that organization. We want to say, hey, we're going to do all our microservices this way now. Well, you really can't if everybody's doing it using their own tech stack and their own stuff. Now, and I don't really know how that's going for them at Netflix. It's maybe working wonderfully. I really don't know. But I think it's, for an organization of 100 developers, something we've probably interacted with a decent amount. The smaller organizations, maybe 50 developers, having a lot of that uniformity, I think buys them a lot in the long term.
I think that's very sound because I think then you get that one, I don't know, voice, but like you said, one direction, not the band, but the process for the code. So everybody, and yeah, I completely agree with that. So let me wrap it up with one last question. So read the book, everyone should go out and buy it. But on pages 180 to 192 are literally thing after thing an organization could do to improve. So it could be a little overwhelming to somebody reading. What would you say are some good areas they can get started with to get kind of a bang for your buck? Are you reading the book right now? Yeah.
I also opened it to that. You gave me the page numbers. I was like, oh, I'll open that. I had it.
Yeah. So literally you guys just give out 12 pages worth of content and things people could do. So I was curious if there's any one you go, yeah, just start with this one.
I think I'm going to try to narrow it down to just a couple.
Okay. Sounds
and
good.
by a couple, I'm probably going to bend the rules and go to like 4.
Okay. It depends. So sounds good.
Yeah. It's yeah. The first is, we were talking about this chief engineer, decide who's making these decisions or how they're going to get made and have someone providing that direction. Because if you don't have that, it doesn't matter what you're doing. You're potentially have a bunch of people running different directions anyways. The next one is, we talked about kind of getting developers to fall in that pit of success. Find what are the changes you need to make to have your developers feel like they can be productive more often. And part of that is we don't want developers to be miserable and not enjoying each day. Think about what are the things that are going to really increase their enjoyment. And probably one of the first ones, and this is kind of part of that, pit of success answer, is focus on that maker time. Let's make sure all the developers have maker schedules almost tomorrow. Get that problem resolved for people. The next, kind of piece of that is there's obviously trying to get some testing in place, getting some better build processes, trying to improve that. Just kind of some of those general hygiene things on your projects will help a lot. It's not going to get you there, but those are easier wins than some bigger changes to make. So that's where I would probably jump straight in, is if you're trying to make a big change, get someone kind of responsible for picking this direction and almost immediately get your developers where they can focus and write code, or at least on large uninterrupted blocks. They need the meetings. They're essential. We can't live in a world without meetings, but we don't want to have a developer's day like it's described in the book, where they're like meetings all over the place and they have no time to actually get anything done.
Awesome. I think those are some fantastic actionable steps. You've been great. You've taken the time. You've answered all my questions. I'll give you a minute to end this on Floor's Yours Grandstand. Promote anything you want. Tell the people what they need to know from Chad.
I mentioned this. I kind of had the book here. Obviously, we'd like you to go get a copy of the book. I don't really want to stand here and promote too much. The other thing would be, Don't Panic Labs here in town. Feel free to stop by and talk to us. We're downtown. We like talking to people. We're a fairly friendly bunch. So yeah, feel free to stop on and talk to us as well.
Awesome. Thank you so much. I appreciate you coming and spilling a whole bunch of great information for everybody.
All right. Thank you. This was a lot of fun. I love the shirt.
Thanks.